Hello, everybody, and thank you for joining us today for Introduction to Codes and Standards. Very topical class these days, as both the Washington State and the Seattle Energy Code are published. And hey, great time to dig into the codes. Class is going to be presented by Eric Strandberg, Senior Lighting Specialist. My name is Armando Berdiel, Technical Development Supervisor at Lighting Design Lab. And again, thank you for joining us. Next slide, Eric, please.
Stand by.
Standing by.
So I have a little dialog box. Here we go. Let's try it now. There we go.
Awesome. Thanks a lot. All right, everybody. As you can see, you're going to be muted during this webinar, but please use the chat feature at the bottom right of the webinar panel. You'll be able to ask us any type of questions, throw us any comments. Every 10, 15 minutes or so, presenter is going to stop and ask for questions. So it's another time where you can use the chat and engage with us. Every so often, we're also going to have online polls. Please participate in these. The more you engage, the better the experience is for everybody. And after the webinar, we're going to have a 1-minute survey. You can tell us how we did, anything you would want to see improved. A recording of the class is going to be available on our website and our YouTube channel, as well as a handout with the slides for this presentation. And if any additional questions or comments, please reach out to our email, lightingdesignlab@seattle.gov. Please be aware we are very much powered by and a part of Seattle City Light. Next slide, Eric, please. But also, it takes a village. We like to work with the full market spectrum of the lighting industry with trade allies, design allies, and our end use customers. But it also takes a village to develop very impactful education and awareness programming of these emerging lighting technologies and best practices. So we work with a lot of organizations in the Pacific Northwest and beyond to make it all possible. Next slide, please, Eric. And we strive hard and work hard to deliver our 4 core service areas: education and training, such as this webinar and classes, technology evaluation, such as demonstrations, pilots, product evaluations. We develop tools and resources, such as our best practice guides or luminaire level lighting control intro videos in our YouTube channel. And we serve as information aggregators. We keep our ears to the ground with the latest and greatest in our industries and disseminate the information to our audience. Now, without further ado, taking it over, Eric.
Thanks, Armando, and thanks for everybody who's attending this webinar. Hopefully we'll have a little fun today with a fairly dry topic. Tried to make it as interesting as possible and cover as broad an area as possible. I thought this was interesting. I saw this a couple of years ago. Electrify everything. So this is a trend that we're seeing for a cleaner, more energy efficient future. This is from Electro Industry Magazine. And you know, one of the sponsors, of course, is the Copper Development Association. So they like to see a lot of electrification. But you know, we're also seeing, you know, kind of at a as a poll on that, but it's also part of the same thing is, I thought this was interesting from the New Buildings Institute. You know, over 700% growth in zero energy buildings since 2012. So, you know, we're seeing a trend towards a lower energy, but a lot of that is going to happen as a result of electrification. You know, so it's a greener technology. So we're going to sort of see how those things play out. As Armando mentioned, I am Eric Strandberg, one of the senior lighting specialists at the Lighting Design Lab. Been there since 1995. I've seen a lot of things come and go. I love lighting and, you know, like to tell people about what's new and different in the topic. Okay, so that's enough about me. How about a little more about you? So we've got a little pop quiz here, a little poll.
All right, thanks a lot. Everybody, first pop quiz opening up. Who are you and why are you here? Are you new to lighting, confused by codes? Do you work a lot in lighting but rarely have time to work with code? Just wanted to see what the latest and greatest or good digestible ways to interpret code. Are you an official or just want CEUs? Thank you for those who have voted. See, the majority have been voting already. So I'm going to close it in about 3 seconds. All right, everybody. Thank you very much for voting. And a great majority of our attendees here, 70%, want to learn what is new with the Washington State energy codes and just the energy code developments that are going on right now. About 20% are new to lighting as well. 7%, hey, want some of the CEUs. So yeah, no, people are interested in what's going on with the codes these days. So good time for the class.
Okay, well, yeah, good. And just so we're aware, I mean, this is a introduction to the idea of codes and standards. So we're not going to get into, it's a topic that people can spend their careers working on, and we're just going to kind of introduce some things. And we do have coming up, once the Seattle Energy Code and Washington State Energy Code are rolled out, we're going to probably try to do a workshop specifically on that topic. We will touch on the 2018 Seattle Energy Code, or rather Washington State Energy Code today, but we won't get into all the details. We want to look at the importance of identifying the authority having jurisdiction. We want to do an overview, as I say, of Washington State Energy Code, and we're going to look at some topics like LEED and the well building guidelines. So, the thing I also want to try to do today is tie all of this back to lighting. So, I mean, the code is all these codes and standards are sprawling documents that cover everything from how buildings are built to how people interact with those buildings in all kinds of ways. And we can't cover all of that, and that's certainly beyond my expertise. But I do know a bit about lighting, and so we're going to try and see how all the codes address lighting issues. So what influences our choices? Well, certainly there's internal influences, and that would be coming from the design team. Your basic goals for the design. There's stakeholder input of different kinds, but again, that would be internal, maybe the owner or maybe other user groups. And then, of course, budget is going to influence lighting choices. Once we go for outside influences, there's voluntary influences. We may be choosing to do a LEED building or a well building. There may be utility incentives that we're wanting to incorporate into the budget process. And then there's going to be possible restrictions there. Dark sky, we may be trying for dark sky. And then, of course, there could be the IS recommended practices. Now, those are recommendations. They are often incorporated into codes and standards, but it's still sort of a voluntary thing, if you will. That said, we do have outside influences that are mandatory, and those would be things like the Life Safety Code, National Electrical Code, OSHA, Americans with Disabilities Act, Department of Health, UL listings, the Washington Administrative Code, the Energy Code, and then, of course, the authority having jurisdiction. So we're going to spend a few minutes on that because that's kind of important, knowing who's going to be the entity to decide what's allowed and what isn't. And that can be a person or office charged with enforcing life safety. For some occupancies types, there's more than one authority, which makes it complicated. So for instance, if you had a hospital, you might have the state fire marshal, you'd have the building official, you'd have fire department, prevention officer, state healthcare and licensing agency, Joint Commission of U.S. Department of Health and Human Services, Centers of Medicare and Medicaid Services, all have a say in how, say, a hospital might be built. If you're unsure, contact the fire marshal, because they ultimately can parse these things out. And they're actually part of the Washington State Patrol. All plan review projects for fire and life safety are in accordance with the state-adopted international codes, and we'll touch on some of those as well. So this I thought was interesting. This is from Electrical Construction and Maintenance magazine from 2015, but I think it, so who has the final say when there's a code conundrum? You know, for residential light commercial projects within governmental jurisdiction, like within a city or municipality, it's often the city, state, or government inspector. But for large industrial facilities, often they're outside of the jurisdiction. There might be in unincorporated areas. Those could be the primary, could be the owner and his appointed engineers. That said, Occupational Safe and Health Administration, OSHA, can override all of that. And so that needs to be kept in mind. And one more piece here. So where public safety is primary, the authority of having jurisdiction may be federal, state, or local. For insurance purposes, an insurance inspection department, rating bureau might be the authority. And then in many circumstances, a property owner or his agents assume the role of authority having jurisdiction. So if you're scratching your heads, I've got this nice little table here that should help you parse this out. It makes it completely clear. Actually not at all. So, you know, we all see all these overlapping spheres of influence, and figuring out who's the ultimate authority is not an easy process. And so, yeah, we'll just bear that in mind. So the National Fire Protection Agency Life Safety Code. So, you know, that covers lots of things, but one area that it covers is egress, how to get out of a burning building, basically. And there's two phrases that come up. One is exit access, and the other is exit discharge. Exit access is stairs and aisles, etc., that lead to an exit within the building. Then exit discharge would be similar kinds of things, corridors, ramps, escalators, leading to a public way, i.e. outside the building. And so we'll see that language come up from time to time. So here's the NFPA illumination, means of egress. And some of you have seen this before. Some of you haven't. Emergency illumination shall be provided for a minimum of 90 minutes, hour and a half, in the event of failure of normal lighting. And to digress slightly, I was in an unusual situation when I was on the road. This was actually in Boise. And there was a power failure in the entire quadrant near the hotel that I was at. And it was winter and everything was dark. No street lights, no building lights. I mean, it was country dark. Here we were in the city, and it was you could, you know, other than the emergency lighting, you couldn't hardly see your hand in front of your face. So we had no TV, no nothing, and I was loath to use my phone much just because we didn't know when the power was going to come back on. So I'm, and it's nighttime. Uh, so I'm reading a book. This is back when I was carrying books around, actual paper books, and so I'm sitting in the hallway near one of the exit lights, the emergency exit lights, and I can read because otherwise I think it was only like 7:30 or, but it was because it was winter, it was dark out, too early to go to bed, nothing to do, couldn't go to a restaurant or anything, they were all closed. So I'm reading, but the light's getting dimmer and dimmer and dimmer. And I was very aware of that 90-minute, pretty soon I wasn't even going to be able to read. So anyway, kind of a funny situation. Normally, if I was doing this in front of a live audience, I'd be getting chuckles by now. Anyway, path of egress, average of 1 foot candle, and then contrast ratios maximum of 40:1. So you can't have, you're trying to minimize too bright to too dark, although 40:1 is a pretty wide contrast ratio. Moving on, one thing that we're seeing now in corridors and other places is controlled, you can use switches and timers, or controls shall be approved. During conditions of stair use, minimum illumination of in new stairs shall be at least 10-foot candles. Existing, other than new, it's down to 1-foot candles. So if an existing building is considerably lower levels required, but in new buildings, it's much higher. So path of egress, sometimes that seems fairly straightforward and simple. Here we have a little office. Here's the door, the lobby. So we can fairly easily see how that might go. And we have our exit discharge area. But if we have a more complicated floor plan, it's not always as clear as you might think. So here we have our door, our main lobby door, and we're exiting to that direction. But we could have other things. So for instance, we have a loading dock. Well, maybe we could just have an exit at the loading dock, but perhaps this is a gated area that's enclosed for controlled access. Here we have a doorway, but maybe that just leads to other storage. Not really sure. This might lead to office areas. So finding the path of egress and exit discharge is not always that straightforward. The other thing that's interesting, we think of a lot of these codes, in this case the fire protection code, as this sort of carved in stone document, but it turns out it's actually language that can be adopted. Often it is, but it doesn't necessarily mean that that's what's in use. Additionally, you want to start by contacting a fire marshal to find out if they're using it, and also ask which edition, because not every area uses the most current edition. They may be using an older one, and that could influence how you move forward. All right, so here we have a little pop quiz.
All right, everybody. So the authority having jurisdiction, what could it be? Select all the answers that apply or could be correct if you believe more than one answer is correct. Thank you for the people that started voting. Good stuff. Authority having jurisdiction could be more than one source, overridden by OSHA, an insurance inspector, the property owner, or the person or office enforcing the life safety code. See still a few votes coming in. Thank you everybody for voting. We'll be closing it in a few seconds. All right, pretty solid spread. 83% call out more than one source, about 60% call out, hey, they can be overridden by OSHA, 28%, an insurance inspector, 38 selected the property owner, and a 66% selected person or office enforcing the life safety code.
Well, and thanks, Armando. And this was a bit of a trick question, because in some cases it could be any one of these or multiple, as we found out. So yeah, it's a tricky situation to know who is the authority, and right. So hopefully that was a little useful. So let's talk about the National Electrical Code. Again, this is something that you think of as sort of a carved in stone type of document, and it sort of derives, it's part of the National Fire Protection Association, the NFPA. You know, despite the term national, it's not actually federal law, but it's typically adopted by the various states and municipalities. And in some cases, they can amend it locally, usually to make it more stringent. You typically can't make these things less stringent, but you do need to know which code you're looking at and which is in effect in your area. So for instance, if you were looking at something in May of 2017, as an example, you'd think that it was one set of documents, but then you go into September of the same year, and guess what? It's now a different document. Doesn't hurt to make sure which one is current at the time of permitting or at the time of inspection. I thought this was interesting too. So the NEC is basically practical safeguarding. The purpose of this code, it's not intended as a design specification or instruction manual for untrained persons. So you can't, they're not intending that you take this book out and tell you how to do proper wiring. Additionally, it goes even further and says the code contains provisions that are necessary for safety. Compliance within it will ensure that you have a safe, free from hazard, but not necessarily efficient, convenient, or adequate for good service. So you could wire things wrong or in a manner that doesn't make any sense. As long as it's safe, you can pass inspection. So bear that in mind. And this gets into, you know, the NEC has, it relates to lighting, has things about storage areas and where lights can be in relation to storage, different dimensions and spacing, so that we don't have things that are electrically energized near combustible material. Additionally, it has, you know, where electrical things can be in relation to water. They don't want people getting electrocuted. So for instance, this chandelier, I'm sure this is actually taken from my second home. But so here we have water. So as long as it's 8 feet above the water line or the high water line, you're okay. And as long as these sconces can't be reached while you're standing in the water, you're good to go. So yeah, these codes impact water and storage. Other things that we look at would be various UL listings, UL and ETL. Occasionally we see inspectors that say, oh, if it's not UL listed, we want to accept it, but ETL is just as good. And sometimes there's language in the documents that only allow for UL, and you need to be able to, that could be old language or something that's just not comprehensive enough. And so ETL is recognized. We occasionally get questions, and then CSA is, as it relates to Canada, Canadian Standards Association, often is accepted in the United States, although you need to find that out. So if you're importing something that does not have UL listing, but maybe is CSA, if that's the plan, you might want to contact your inspector and say, hey, these are CSA, will you allow them? And if they say no, you might either look for a different fixture or try and work through the paperwork so that you can get them signed off. So some things that we see with these UL ratings are how like a luminaire, a light fixture, might be relating to dampness, water. Occasionally, most light fixtures that you buy are going to be damp location, even if they're for interior. It's pretty rare that you see dry location, but you do occasionally see that. So you want to be careful that you're not purchasing something that's dry location only, but usually it's damp location or wet location. And then there's language about what those definitions mean. Another thing that we see a lot is the so-called IP ratings, ingress protections. And those are for liquids, either flowing on or even sprayed at different angles and different intensities, or even fully submerged. And so the higher the second number, so the IP, we often hear IP66 is one thing that we see for like street lighting or exterior. And that second number would be the water, but the first number has to do with dust, particulate matters, solids, that sort of thing. And you can have, of course, no protection. You could have a 0, so you could have no protection against some material, and that you need to know about, although I've never seen that listed as such. So bugs, right? So we can see bugs getting into fixtures. That would be a solid, and so you might wonder about your gasketing. It's interesting, even though something may be IP66, it still may allow bugs to get in. Not sure how that works. The ADA, the American with Disabilities Act, when this came online, gosh, I don't know, 20, 25 years ago or so, it was created, it was quite a big deal, especially for luminaires that were mounted to the wall. There was rather strict and new standards, no more than 4 inches projection out from the wall within an 80-inch to 27-inch zone there. And so lots of manufacturers had to retool and come up with new fixtures that did not project out. And this makes a big difference. So this is why we care. Something might look great and you're building a hotel that's got a theme and you've got these interesting fixtures, but if somebody can't see that, it's going to be a problem. International Building Code is part of a family of international codes, and the International Code Council, the ICC, oversees all of this, and they address design and installation of innovative materials that meet or exceed public health and safety goals. And so we'll see the IBC referenced from time to time. OSHA, Occupational Safety and Health Administration, they have requirements for certain types of areas, like construction sites, as an example. So the general construction area might require a certain amount of foot candles. Other areas might require more or less, depending on what kind of activities take place. Not less than the minimum illumination. So for instance, offices, and if you have on a job site, you might require at least 30 foot candles in that office, as an example. Those would be minimum foot candle levels. Marine terminals has caused a lot of headaches for, especially this 5 foot candles number, for people working with the port and other areas like that. And sometimes these numbers, especially when you're looking at modern equipment, maybe that have higher color rendering capabilities, this number is not necessarily required. It may be a little stringent, but at any rate, it does. You need to know that that's a number that's going to be out there, and you have to try and either meet that or come up with a good justification why you don't need to be there. So, all right, another pop quiz.
Coming right up. All right. Calling out the Egress projections rating. Define and please select all the answers that could be correct for you. Egress protections ratings defined could be: are they a wet location? Do they have protection against dust? Protection or no protection? Protection against solid objects? Or they measure the duration of immersion? See people voting. Well, over half. Thank you everybody for participating. Closing in about 3 seconds. All right, thank you for participating. We have about 58% of the people called out a wet location. 77, the majority called out a protection against dust. 23% called out no protection. 50% protection against solid objects. 42% call out the duration of immersion.
Okay, well, thanks, Armando. Yeah, so it's, this is a little tricky here. So wet location is actually UL listing, although the IP ratings do address liquids. The dust, of course, is one that they refer to. They do have a no protection listing rating, so that would be a 0. So in theory, you could see that. Solid objects, again, are dust. And then duration of immersion, they talk about. We kind of glossed over that a little bit, but if you're looking at in the handout, if you look at the listing, they do talk about some of the more like IP. I think it's a 7. And allows for a certain time that the luminaire can be submerged and still maintain safety. So, all right, well, good. Thanks for doing that. By the way, Armando, do we have any questions coming through in the chat? I'm thinking probably.
Sorry, I was on mute. And no.
Yeah, okay.
Yeah.
Great. All right. So Office of Superintendent of Public Instruction, school facilities. So one thing that came online a number of years ago was the Washington Sustainable Schools Program, WSSP. And it sort of relates to LEED. So you can, state-funded school construction projects required to either follow the sustainable schools or LEED model. And interestingly, this is a self-certifying standard, so meaning that the school district just applies to the state to show that they're meeting those particular standards. But let's take a look at how that might read, and we'll also see how that might have, we'll talk about the WAC, the Washington Administrative Code in a second. So required is all of these different things here, this top section, and we're just going to focus on one of them. I mean, it talks about end of life or conditions for the lamps. This is all about lighting, contrast ratios, etc. But we're going to look at one here, pop this one out. And in general, illumination mode achieve an average illumination of work plane compliance that would be at 3 feet above the, rather at the work plane, which would be 30 inches. Minimum of 20-foot candles for general spaces and 35-foot candles for special instruction. At any point 3 feet away from the wall, so they're not looking in, maybe dark corners, but in the general open area. And we'll see that these numbers might be a little bit in question. All right, and so then, so once you've met that, after meeting the above requirements, you can get an extra point. It's a sort of a point system like we see with LEED. If you dim all the luminaires in the classrooms, excluding the whiteboard. And if you do, once you've done that, after you meet all the above requirements, you can then change the color of the luminaires. I think what they mean is the color of the light coming out of the luminaires. It doesn't mean you get to repaint the luminaires from white to green. But at any rate, change the color of the light. So that would be an additional point. So if you have color tuning, so this is a, even back in 2015, they were looking at that kind of opportunity. So the Washington Administrative Code, the WAC, it is a vast document. It goes from Title I all the way down to Title 516. And it covers all kinds of topics, everything from air pollution to agriculture to transportation to various colleges. For instance, in this case, the WAC, as it addresses assisted living facilities, I thought this was a fairly bizarre case of a assisted living facility, sort of neighborhood corridor. Haven't seen that before, except maybe in Las Vegas. But at any rate, from a lighting standpoint, some of it's a little vague. Assisted living facility must provide enough lighting in each resident's room to meet the resident's needs, preferences, and choices. Well, that doesn't really give us a specific thing, although it does state here, new assisted living facilities must at a minimum meet the IES recommendations for lighting in the common areas. But in the living spaces, it's not clear. I will say that this can be, I worked on we consulted, the lab did, on a project that was denied. They couldn't open. It was an assisted living facility that didn't have enough light in the corridors. They just put in recess cans, compact fluorescent recess cans, like you might see in a typical apartment complex. And it wasn't enough light. And so they either had to add more fixtures or somehow change the fixtures that were there. It was a real problem for them. And they weren't allowed occupancy. And so you do need, so this does have some teeth, and you need to look at that, especially in areas where they do call out specific recommendations. Here's another one for early learning in toddler and infant sleep practices. Sufficient lighting in the room in which an infant toddler is sleeping to observe skin color, right? So they want to see if one of these little kids is maybe turning blue or something. So it can't be so dim that they can't be observed. And thought that was interesting. It doesn't really say what that number is, though. So again, it's a little bit vague. The WAC, as it talks about schools, following provided as measured 30 inches above the floor. You want to avoid excessive brightness and glare and minimize shadows. And so they're looking at these light levels: general instruction, 30-foot candles, study halls, lecture rooms, special instruction in terms of laboratories, shops, etc. But when we compare that to the Washington Sustainable Schools, we were looking at 20-foot candles for general instruction spaces and 35-foot candles for special instruction spaces. So not sure which would take precedent there. I'm guessing the WAC would, but that would be a point of debate, perhaps. We've touched on the IS, the Illuminating Engineering Society, their recommendations. This is in the 10th edition, still the current edition. You know, and they'll provide numbers for all kinds of reading tasks, as an example, if pen tasks or computer, printed media, etc. And they're looking at 30 to 40-foot candles. These are lux, 300 to 400, which comes out to around 30 to 40-foot candles. So they're making statements about those things. And we're going to get into, you know, looking at the energy codes, and there's a relationship between the energy codes, which have lighting power density requirements, and the IS recommendations. So in theory, these power density requirements are based on modeling to achieve light levels recommended by the IES. So for instance, you can't say, well, we want, you know, half a foot candle, where in a space that's required to have, maybe recommended to have, you know, 100-foot candles. That might be difficult to achieve with normal modern equipment. Recently, the IES sent out an RFP, request for proposal, to remodel some of these spaces. So provide computer modeling to show the to just revisit some of the recommendations, and so that was a project that took place a couple of years ago. Not quite sure where they are on that. So when we look at the energy codes throughout the country, we see that different states have different ASHRAE code acceptance based on different years. Some don't have a statewide code, although, again, this is from actually just earlier this year. So I think they have to have something. I think they do it based on counties and cities. Here we have ASHRAE and the IECC, and they work sort of together. There's some states adopt one or the other, but they've aligned themselves over the years so that they're fairly close, and there's not a lot of differentiation between them. Entities may make modifications or amendments. Of course, we've seen Seattle. So there's Washington State Energy Code, and then of course Seattle has its own energy code. It can be stricter. It can't be less strict. Let's see. And sometimes different codes are enforced for different building types. So whether it be residential, commercial, or whatnot. And again, these are part of the IECC, the ICC rather, database. This is a fairly handy website to check out, and it will help you determine which particular codes are in effect in different areas. So for instance, in Washington State, this is still current, even though it says 2015, this State Building Code Council We have the International Building Code, the International Energy Conservation Code, IECC, 2015 International Fire Code, etc. And this also is not a bad website to check out in that it has who to contact. And here we have the fire marshal, the state fire marshal. If you need clarification on these are links to some of these codes, so it's not a bad thing to have. But as I say, we Washington State. I know we've got some other states that people from different states who'd registered, and we welcome you to the broadcast. And just know that I think that throughout the Northwest, except for Oregon, we pretty much use IECC, but different. I think some of the states have 2013 still, some have 2015. Washington State is 2018. So you just need to look at which is in effect in your area. Okay, another pop quiz.
Awesome, awesome. And we are going after ANSI ASHRAE IES lighting power density limits. What are they based on? Please select all that apply. Are they based on wishful thinking? Are they based on computer modeling? Application of standard modern lighting equipment? Achieving IES lighting recommendations? Or they're based on available energy? Please select all that apply. All right. Good amount of people already voting. Thank you guys for the prompt participation. Especially thank the ones that are selecting wishful thinking.
Yes.
Yeah, I'll leave for a few more seconds. All right, and we're closed. We got a few people, 8% calling out they're based on wishful thinking, but these LPD power limits, 79% call out computer modeling, 71% call out application of standard modern lighting equipment, 88%, the majority vote call out to achieve the IES lighting recommendations, and 25% of the people selected available energy.
Okay, well, thanks, Armando. And yeah, this is kind of, yeah, I'd love wishful thinking too, but yeah, that it seems like that might be the case. But it's really, you know, computer modeling, a combination of IS recommendations, computer modeling, and applying those with standard modern lighting equipment. Available energy isn't really, you know, that's kind of how we went before there was any code. If, you know, we just put in as much equipment as we could until we ran out of power, and that's kind of what got us in the state we're in today. So we're not doing that, hopefully. All right, so let's take a look at the Washington State Energy Code, and kind of as I suggested for folks in the outside Washington State, you know, we're really not looking specifically. I mean, we're looking at using the Washington State Energy Code as a model, but really this is you'll find similar language in other states and jurisdictions. Even in Seattle, the language will be similar. And we're mostly just trying to give you a way to approach the code and show you the areas that it addresses, and not all the areas. And I've edited a fair bit of this out, otherwise we'd just spend all day reading, which we're not going to do today. But so it covers, we're going to cover the scope and requirements. We're going to look at little definitions, electrical power lighting systems, energy efficiency options, system commissioning, and then we'll touch on existing buildings as we go. Okay, scope and administration. So it starts right out. This code shall be known as Washington State Energy Code and shall be cited as such. It is referred to herein as this code. So, this kind of convoluted language does not instill confidence in me, even though I kind of know what they're trying to say. So the intent is to provide flexibility, permit the use of innovative approaches and techniques, as long as it doesn't abridge safety, health, or environmental requirements containing in other applicable codes or ordinances, and we'll touch on that. But overriding all of this is safety, health and safety. So yeah, one little bit though that is stuck in here, and I think there's an exemption. So this code applies to commercial buildings and the building sites associated exemption, temporary growing structures used solely for the purposes for the commercial production of horticultural plants, ornamental plants, flowers, etc. So this is kind of some new language that we've seen, and we'll touch on that a little bit later. One way people sometimes get in a little bit of trouble is they sort of try to cherry pick things. They'll read the part they like and ignore the part they don't like. And they're very clear here. Where in specific cases, different sections of this code specify different materials, etc. The most restrictive shall govern. Right, so you can't say, well, it says this part over here and it's a little more stringent over here, I'll pick the more general area. Where there's a conflict between the general requirement and specific requirement, the specific requirement shall govern. And it goes into the reference standards. So they refer back to other documents. They say they're listed in chapter 5, but it's actually chapter 6, near as I can tell. Maybe somebody knows something I missed, but at any rate, we'll ignore that for the time being. But conflicts where differences occur between provisions of this code and reference codes and standards, the provisions of this code shall apply. This code as applicable shall take precedence over the provisions referenced in the codes and standards. So let's take a look at what those are. So here's some reading material for you. All these different documents apply to the Washington State Energy Code. They're referenced somewhere or another. The good news is I've picked out the ones that apply most to lighting, and we have ANSI, we have ASHRAE, Department of Energy, IEEE, ISNA, the IS, the NEMA, and UL. So those are the ones that are going to be most applicable when it comes to lighting. But now there's a few tricky ones in there. All right, so let's take a look at definitions. There's over 150 definitions at the beginning of the document, and they're defining everything. They're defining a wall. In case you were wondering what a wall was, they have a definition for that. Some popular definitions that come up is commissioning. What is building commissioning? Daylight responsive control. What is a dwelling unit and how is it different from a sleeping unit? General lighting as compared to uniform illumination. Time switch control. So some of these are all things that are defined and you might want to know about. Lately, there's been lots of interest in things like controlled plant growth environment, greenhouse, temporary growing structures. So notice temporary greenhouse. What is it? I suppose it's not temporary. And then commercial energy efficiency, some highlights. So we're just going to go over some of these things. So general, this section covers lighting systems controls. It starts up with controls, maximum power densities, electrical energy consumption, vertical and horizontal transportation systems. So it gets right into dwelling units. It talks about what is a dwelling unit and what is a sleeping unit and how they're differentiated and which of these different code sections apply to which. General, so we're lighting controls. Lighting systems shall be provided with controls that comply with one of the following. Controls as specified through these sections 405.2 through 405.27. So there's a bunch of sections that refer to controls, or luminaire level lighting controls as specified below. They shall be independently configured to monitor occupant activity, monitor ambient light. It should be wireless zoning configuration. The so-called LLC means you don't necessarily have to worry about all these other things. Controls general continued. So the exception is, except for the specific applications controls required in this section 405.2.5, lighting controls are not required for the following: areas designated as security emergency areas, means of egress, emergency egress, and industrial manufacturing areas as may be required for production and safety. So this is kind of a big loophole for factories and manufacturing. So let's take a look at what some of these .1 through .7, and then we'll look at another .8. Okay, so occupancy controls, location. So typically they'll talk about a control and they'll say where it's located, and then they talk later about what it's supposed to do. So where are they located? So occupancy sensors, well, pretty much everywhere now. All these spaces, and some of these I highlighted that are somewhat new: enclosed stairways, service corridors, covered parking areas, open plan office areas. So Seattle code, I think, has been requiring them in some areas, some of these before, but Washington State is now adopting these. And you do need to be careful that there's some differences between Seattle code and the Washington State code. So what is the function? What's the occupancy function? What do they need to do? Occupancy sensors shall comply with all of the following. So they need to have turn off after 20 minutes, manual on, or shall be configured automatically on only to 50% power. There's an exception: full automatic on controls are permitted in these kinds of spaces where manual on would endanger safety. So restrooms, stairways, and whatnot, the lights come on to 100% as opposed to 50%. Continuing, so in different, then they go and talk about different spaces where there are the occupancy sensors. So warehouse and storage areas automatically reduce lighting power by not less than 50% within 20 minutes. So they have to reduce the power, but you can't just notch it down 10%. It's got to go down to not less than 50%. And then there's various other things. So we have, they discussed this for warehouses. We just looked at open plan office areas, parking in garages, which we won't go into the details on, but you would look at that. But now for sensors controlled in enclosed fire-rated stairways, automatically lose lighting power by not less than 50% when no occupants have been detected. However, all portions of the stairway shall remain illuminated. So you can't have the lights go out completely, but they can go down when nobody is around, but just not turning them off. Time switch controls. We talked about occupancy sensors. Now let's look at time switch controls, their locations. Where do you need them? Time switch controls. Each area of a building that is not provided with occupancy sensors or digital timer switch shall have a digital timer. Exceptions: where a manual control provides light reduction the time switch controls shall not be required for the following: spaces where patient care is provided, spaces where automatic shutoff would endanger occupants, lighting intended for continuous operation, and shop and laboratory classrooms. What is the function of these time switches? You know, they have to have a 7-day minimum clock. That's pretty standard now. Automatically turn light on to full power in areas. In all other spaces, though, the time switch controls are allowed to automatically turn the light, turn the lighting to not more than 50% power, unless you want to override it. The manual controls. All lighting shall have minimum manual controls complying to the following. They shall have a location with ready access to occupants, located where the controlled lights are visible. All right, so we can't have these control rooms or breaker panels someplace where you can't see what you're controlling. Exceptions are spaces with purpose of safety and security, provide remote control device. It needs to have an indicator light, and also they're accepted in restrooms. You can't have manual control in restroom areas. Light reduction. So light reduction controls, manual controls shall be configured to provide light reduction control that allows the occupants to reduce the connected lighting load between 30 and 70%. And shall be achieved by one of the following approved methods. So we can either control all lamps or luminaires. And what do we call this? Normally we'd see a show of hands, and this is in fact dimming. Dual switching alternate rows of luminaires, switching the middle lamp of luminaires independently with outer lamps. We call that inboard outboard. And this is kind of an old technique that would only make sense if you were using fluorescent lighting. So probably not seeing that in new buildings or new construction. Exceptions would be spaces that have only one luminaire of less than 100 watts, and spaces that use less than 0.6 watts per square foot. So if it's a low power area, you don't need light reduction controls. Daylighting zone. So we're not going to talk a lot about daylighting. It's a pretty big chunk of the energy code, but I do want to touch on it in a couple spaces here. Primarily, we want to know, especially for people who are just starting out, side-lit zones and top-lit zones. So side-lit zones are windows where you've got daylighting coming in from the side of the building, and top-lit zones would be skylights where you have light coming in through the roof. So we are required in many areas, but some exceptions where they're not required are some like healthcare facilities, lighting for specific applications, which they call out. But I thought this one is worth mentioning. Side-lit zones on the first floor above grade in group A2 and construction group M occupancies. And A2 is basically restaurants, and M is mercantile, which would be retail spaces. And that would be because, as we know, if these lights were off in their storefront, it might look like this shop was closed. And so there's a real issue there with sending the wrong message to potential customers. One thing that used to be in the older code was dwelling and sleeping units, and that's no longer in this new code, the 2018 code. That hasn't gone into effect yet, but when it does, we'll need to do daylighting controls in those facilities. Additional lighting controls. So specific application lighting controls shall be provided with controls in addition to the controls required by other sections. In addition, a manual control should be provided to control such lighting separately from the general lighting. So if you're doing accent or display lighting, that would be in addition to your general lighting, but you have to have it controlled separately. Supplemental task lighting, display cases, things of that nature. Sleeping units. So automatically switch off all permanently installed luminaires and switched receptacles within 20 minutes after the occupant leaves. Exceptions would be where you have a key card control. Some of you maybe have been into hotels, newer ones perhaps, where there's a key card which basically does what this would do. Permanently installed luminaires within dwelling units shall be provided with controls complying with either of these sections. Additional controls, lighting for non-visual applications such as plant growth and food warming. Each control zone should be no greater than areas served by a single luminaire or 4,000 square feet, whichever is larger. All I can say is 4,000 square feet of French fries is a lot of French fries. Luminaires serving exit access, providing means of egress illumination, shall be controlled by a combination of listed emergency relay and occupancy sensors. So we're no longer seeing these so-called 24/7 safety lights, where you leave a space, an office or corridors or kinds of places, gymnasiums, and there's these lights that just stay on 24/7, and they're so-called safety lights. Those aren't allowed anymore. And so they can be part of the same system, but they just need to be controlled by a relay. Exterior. Requiring controls from these sections. Exceptions are lighting for covered vehicle entrances or exits, where we'd see lights that might be on all day. And lighting controlled from within a dwelling unit. So we've got apartments. These lights are controlled from within, and so they're not subject to the normal exterior automatic controls. Daylighting shutoff. Lights shall be configured to automatically turn off when daylight is present and satisfies the lighting needs. Not quite sure. That seems a little vague. An exception for facade lighting shutoff, areas where automatic shutoff would endanger safety or security. Again, that's almost always going to be an exception. Continued on that same subject, lighting setback. So what they're wanting is for timers, automatically reduce the light by not less than 30% during one of the following times, either from 12 to midnight or not later than 1 hour after business closing and not earlier than 1 hour before business opening, and during any period when no activity has been detected for 15 minutes or more. Time clock functions shall be capable of being programmed for not fewer than 7 days, and they shall be capable of being set for 7 different types of days per week. So you might have Monday is different than Thursday, maybe have short hours on Monday, but longer hours on Thursday. Maybe Sunday is different than Saturday. Maybe you're not open Sundays, but you're open Saturday for either longer or shorter times. So you need to be able to adjust all of those different days. Okay, this looks like an eye chart, and I apologize, but I just wanted to get everything on this one slide. But basically, this is, we're not going to read it all, but this is the interior lighting power allowance calculation. Total connected lighting power is based on adding up all of these different things here. For luminaires with lamps connected directly to building power, such as line voltage lamps, we've got the loads for transformers or ballasts, track. So here with track, we take that and we look at the watts per linear foot. We're allowed a certain amount. In this case, it's 16 watts per linear foot. And guess what? It used to be 50 watts per linear foot. But in the days of LEDs, 16 watts per linear foot is pretty easy lift. It does mean that if you're using incandescent lamps, you're not using very many of them. And then here we have power over Ethernet. And this gets a little interesting. So that would be the maximum rated input wattage of the driver, power supply, and transformer. However, non-lighting devices may be subtracted. So if you have cameras or sensors or other things on your PoE system, you can subtract those from the total lighting power allowance, because again, that's lighting. And then anything that doesn't fall into these categories would be all other luminaires and lighting sources not covered above and associated with the interior lighting. So there's exceptions. Things that we don't include in our total lighting power allowance would be sports arenas, emergency lighting that's automatically off during normal business hours, casino and gaming areas, mirror lighting in dressing rooms. I circled this one just so I could include this funny picture. And then task lighting for medical and dental purposes. There's a lot more exceptions, so we're still into exceptions. So this is 1 through 7, and now we're into 8 through 21. All kinds of things are exceptions. Display lighting, in addition to general lighting and controlled separately. Performances on stage, task lighting for plant growth, food warming, again, not included in the lighting power density. Lighting approved for safety, automatic shutoff, task lighting, aircraft painting. So yeah, goes on and on. So we have two ways to determine the lighting allowed in this total interior lighting power allowance. We can either use the building area method or the space by space method. The building area method is the floor area for each building area type listed, which we'll look at in this table, we'll look at in a second. And then space by space, that most closely represents the proposed use of the types of spaces. And with space by space, excuse me, trade-offs among spaces are permitted. We'll look at that in a second. So building area method, I mean, sometimes it's pretty straightforward. So you get this table, building type. Here we have an auto repair. So it's automotive facility. We get 0.6 watts per square, 0.64 watts per square foot. What is this building? I think it's a library, and they get 0.83 watts per square foot. But if we go to some other types of spaces, maybe it's not so clear. Is this a motion picture theater? Is it a performing arts theater? Is it a town hall? Well, how we determine it really has a pretty big difference. We could either go from 0.44 watts per square foot to 0.84, depending on what kind of space it is. Just a little thing here, the lighting power allowances over the years, it's getting smaller. So if we go back to 1998, we see that, say, for cafeterias, we had 1.5 watts per square foot. Food establishments now, actually, it's separated out into some different types, but they're all about half of what you had before. Same thing with libraries. Again, about half. Office buildings, about half. What's interesting with warehouses, it was 0.5, it only went down to 0.4. I think maybe these were already using, they didn't typically have incandescent. It was usually, even back then, it was metal halide or high pressure sodium. So it's really hard to get that number much lower and still maintain safety. So if we do space by space method, instead of just declaring, say, a library or an automotive facility, we say, well, we've got an atrium that maybe has either a 20-foot ceiling or maybe over a 40-foot ceiling, and we get a certain amount of watts per square foot based on that. Maybe we have an office, and depending on whether we're doing it in enclosed offices, large or small, or open plan, we get different lighting power densities. We talked about trading spaces, so we could have the restroom facility. Maybe we don't need so much, we can have a lower power density there, and so we can add some of that we didn't use to the office, or maybe the stairwell, we can do the same thing, that kind of effect. So if we use the building area method, we get 0.64 watts per square foot for an office. If we use space by space, it's a little harder, but we may end up getting more watts per square foot, especially with trading. It just depends on what you want to do. You know, the good news is if you're using modern equipment and a decent design, most of you're going to come in below your allowed power density for the most part anyway. So here we have space by space, some of the footnotes. So if we go back, won't go back too much, but here we have like a footnote N, or we have footnote B, footnote A, those sorts of things. So if we look at some of these footnotes, so for a lobby as an example, footnote C, for spaces in which lighting is specified to be installed in addition to and controlled separately from the general lighting for the proposed of highlighting art or exhibits, you get extra half a watt per square foot. For classrooms, additional lighting power allowance of 4.5 watts per linear foot for white or chalkboards. For directional lighting dedicated to the white or chalkboards, it says here for P, for offices, in addition to lighting power allowance of additional lighting power of 0.2 watts per square foot for portable lighting, as long as it's controlled by a time clock or aux sensor. However, I didn't really see a footnote there, even though it says there is one. So I'm not sure quite what happened there. It's probably just a little typo. And I guess I should say, any language that I have here, these are direct snips from the code itself. These are copy and paste. So the language might seem a little tortured, and that's because that's how they do it. So here's another one from the footnote. So a library, footnote F, in the reading area is footnote N. So footnote N, additional lighting power allowance of 0.3 watts per square foot for ornamental lighting. Qualifying ornamental lighting includes all these things. It does not serve as display lighting or general lighting. So you might question some of these, you know, would this be perhaps a task light? These would probably be considered general lighting and would be would be counted. You wouldn't get the addition for that, but you might for these task lights. So again, sometimes it's not exactly clear which fixtures apply and which don't. And then in the old code, the 2015 code, the F, they had a watts per square foot for higher spaces. You added a 2% every foot above 9 feet. And of course, you've got a quite high ceiling here. But that's gone from the current code. It just has reserved. So maybe that's no longer an option. Again, another very dense slide, I apologize, but we'll just touch on a few of these areas. So here's retail. Additional interior allowance controlled separately from the general lighting to be turned off during non-business hours. So the way retail works is you get a certain power allowance, and then you get additional interior lighting power allowance of 500 watts, no matter what kind of retail space it is. And then depending on whether it's retail area 1, 2, 3, or 4, you get multipliers of additional watts per square foot. So retail area 1 would be all products not listed in retail areas 2, 3, and 4. And so then we have things with sale of vehicles, sporting goods, furniture, crystal, jewelry, china. So and these could be specific stores, but you go to even like a Fred Meyer, and they're selling china, and they're selling furniture, and they're selling food, and they're selling sporting goods. So different areas of the store would get different lighting power allowances. Exception, other merchandise permitted areas, retail areas 2 through 4, provided that justification documenting needed for the additional lighting power based on visual inspection and approved by the code official. So you always want to get these things approved in advance so you don't have any problems later. Exterior lighting. So exterior lighting, building grounds. So we're looking at 50 watts. All exterior building grounds and luminaires that operate at greater than 50 watts shall have a minimum efficacy of 100 lumens per watt. That's a pretty high number. Really, that means you might get metal halide and high pressure sodium if you're still using those, but you're probably not going to be able to use anything other than LED. So no compact fluorescent and no fluorescent in most cases. Unless the luminaire is controlled by a motion sensor or qualifies for one of the exceptions. And then the exceptions would be if you have solar powered lights. Of course, they're not using local power, or they're using only local power, nothing off the grid. Luminaires controlled by a motion sensor, mentioned here, and luminaires that qualify one of the exceptions under the section, which we'll look at on the next page. Total connected exterior lighting power is everything on site that's powered through the energy service of the building. So you may actually have fixtures on site that are controlled from some other source, either maybe city power or county power, perhaps, and those wouldn't count. So all these exterior exceptions, we're not going to go through them all, but lighting improved for safety, emergency lighting, exit signs. But then we have like advertising and signage, athletic play areas, lighting integrated with or used with highlight features of art, public monuments, national flags, and then lighting, as we mentioned earlier, controlled from within dwelling units. So exterior lighting power allowance. Basically, lighting power allowances are specified. The lighting zone for the building exterior lighting is determined in accordance with this table over here, unless otherwise specified by the official code. So we have different lighting zones, developed areas, national parks, state parks, rural areas, areas predominantly consisting of residential zoning, neighborhood businesses, light industrial with limited nighttime use. All other areas not classified in 1, 2, 3, or 4. And then 4 would be high activity commercial districts in major metropolitan areas. So trick question here, what zone is City of Seattle? Well, some of you might know that Seattle doesn't allow zoning 4. So they're considering themselves zone 3. I think it's interesting, I could be wrong, but I think the city of Bellevue considers itself zone 4. But again, obviously we'd be looking at, Las Vegas, Times Square, New York City, some of these other areas where you have a very busy, active, and again, these are determined locally. So what we do is we, depending on what your zone is, you get a base site allowance. So if you're zone 2, you get 400 watts to do with whatever you want. And then after that, for parking areas, you get 0.04 watts per square foot. Walkways, this gets a little interesting. Walkways and ramps less than 10 feet wide, you get watts per linear foot. If it's greater than 10, if a walkway or ramp is greater than 10 feet wide, it's a watts per square foot. So you just want to make sure that you're counting it right. And again, that would be pedestrian entrances as well. We were looking at watts per linear foot. And then we go for other things, watts per square foot. So you just want to check on that. So these are these areas you get. Down here, you don't get an allowance. If you have an ATM, it doesn't matter what zone you're in. You get this number of watts. It would matter in some cases for building facades, as an example. You can't light building facades in national parks or rural areas. But you might have an automatic ATM. You might have a gatehouse of some kind. You might have loading areas for, in hospitals and fire, drive-up windows. You can't trade these around though. You can't say, well, I'm going to use this wattage that I would have had if I had an automatic teller and apply it to my loading area. So you either have it or you don't. Parking near 24-hour retail entrances, this seems a little vague, and it's not really called out what that means. If I have a 7-Eleven, are all of the parking lots near the entrance? Probably. If I have a Home Depot, are they all near the entrance? Probably not. But who's making that determination? Additional power shall be used only for the luminaires that are serving these applications and not be used for any other purpose. So you can't trade these around the way you can for some of these other spaces. Okay, another pop quiz.
All right, and it's been a pretty solid amount of time talking about the interior lighting power calculations. So, excuse me. Selecting. So the two methods for calculating interior lighting power are they the building area method, the accepted method, the space by space method, instrumental method, or the Stanislavski method? Proud of myself how I was pronouncing that last one.
You nailed it.
Seeing the voters come in. Thank you guys for participating. We'll do it for a few more seconds. All right, close it, Eric. You're doing too good of a job. Everybody selected 100% building area method and another 100% space by space method. Not
Yes.
for one.
No method actors in the audience. Okay, well that's understood. All right. Yeah, great. Well, oh, by the way, in case you were wondering, gas lighting shall not be equipped with a continuously burning pilot or ignition system. So, you know, just saying. But that's in the code. All right, so we mentioned earlier, think way back, we talked about vertical and horizontal transportation systems and equipment. Well, that would be elevators mostly. Elevator cabs, the lighting in the elevator cab can be not less than 35 lumens per watt. And basically what that means is no incandescent in elevator cabs anymore. So you got to find creative ways to light the elevator cab. And with the in this LED age, I don't think that's going to hold anybody back. Remember all those documents that you might want to be aware of, all those sources to the code. Well, this isn't actually in the code, but this sort of sneaks in through the American Society of Mechanical Engineers, and they're getting busy in the lighting space, unfortunately. And this could come back to haunt you perhaps, but elevator lighting, elevator landing illumination shall comply. And basically illumination at the landing sills, building quarters shall be so lighted that shall be not less than 10-foot candles illumination under emergency power shall when the elevator is in service, and in emergency power it's different. So that you need to know about. So if you're putting little pools of light down the middle of the corridor in your exclusive hotel or your nightclub that's on the 8th floor, you might want to be aware of the fact that you need light at those sills. But wait, there's more. So we're talking about lighting, but we're also talking about switched and controlled receptacles. At least 10% of all receptacles, at least 50% rather, need to be controlled. Receptacles should be visibly differentiated in some way. Sometimes they're just a whole different color. Shall be controlled by one of the following automatic control devices: an occupancy sensor that turns off after 20 minutes, or a time of day operated control device that turns receptacles off at a specific program times. Exceptions, of course, would be for safety and security. We're not controlling off equipment, turning off equipment that would create an unsafe condition. So now we have additional energy packages, additional energy efficiency credit requirements. So there's a bunch of these that you can pick from, which we'll look at in a second. And you need to accumulate 6 credits, a minimum of 6 credits with these additional energy options. And the exceptions would be low energy spaces. So if it's already a very low energy space, you don't necessarily, shall comply with the table to achieve a minimum of 3 credits, or if it's less than 1,000 square feet, to achieve a minimum of number of 3 credits. So if you've got a small space, you don't have to go up to the full 6 credits if you've got any of those types of spaces. Maybe it's a LEED Platinum building, or maybe it's just a tiny little addition. So here's all these things, and most of them have to do with mechanical systems or building envelope. But there's a few that relate to lighting, and so we'll touch on those. And these refer to groups R, Group B, Group E, N, etc. And so I've listed what these are. Astonishingly, the group letter aligns with its use, so assembly, B for business, E for education, M for mercantile. I think it's kind of old style. I think they might call it retail, but residential, maybe that's why they use the R for residential, storage, etc. So we have if you're using, so here's, for instance, 2, if you've got say a retail space and you conform to that, you get 3 credits. If you conform to number 3, you get 6 points right there. So you can't combine the points, so you can't take 3 and 1 and make 4, but you can use one or the other. And then there's a controls credit, which we'll look at. So reduce lighting power, option 1. So you either use one or the other. Interior lighting power calculated shall be 90% or less of the lighting power values in these tables. So you take this and it'd have to be 10% less than the number indicated. Or if you go to 80% less of these numbers, then you get additional credit. So you pick one or the other. And then there's a lamp fraction for residential dwelling units or sleeping units. Not less than 95% of permanently installed light fixtures shall be provided by high efficiency lamps with a minimum efficacy of 65 lumens per watt. And then enhanced digital lighting controls and the exceptions. So not less than 90% of the total installed interior lighting power and whole building or tenant space shall comply with this. Luminaire shall be configured for continuous dimming. Each luminaire shall be individually addressed. That's kind of a biggie. Exceptions would be multiple luminaires mounted on no more than 12 linear feet of track, so they don't have to be controlled individually, or multiple linear luminaires that are ganged together to create the appearance that's not more of one fixture, not more than 12 feet. So if you have a 12-foot fixture that's that's 3 4-foot sections, they don't all have to be individually controlled. Just as one unit. And then no more than 8 luminaires within a daylight zone are permitted to be controlled by a single daylighting control. Exceptions continued. Luminaires shall be controlled by a digital control system that would have scheduling and illumination levels of individual luminaires, have some sort of provision for load shedding, either by demand side or high-end trim, can be individually adjusted by the occupants, and it has occupancy sensors and daylight responsive controls are capable of being configured throughout the system. Additionally, construction documents shall include submittal of a sequence of operations, including specification outlining each of the functions. So you can't just throw in all these controls and not have a plan. You need to show what your sequence of operations is going to be. All right, so those are the additional controls. Now we'll look at existing buildings. General. So this is section C500, C501. So the scope provisions of this chapter shall control the alteration, repair, addition, and change of occupancy of existing building structures. Existing buildings, except as specified in this code, shall not be used to require the removal or alteration of, or abandonment or prevent the continued use and maintenance of an existing building within the system that's lawfully in existence at the time of the adoption of this code. So what that means is if you've got a building that's, lawfully in existence, and you're changing it in some way, you don't have to alter the rest of it as long as it's functioning well. Compliance alterations, repairs, and additions, and changes of occupancy shall comply with the provisions for altering repairs as seen in the International Building Code, NFP, National Fire Prevention 70, and some of these others. So the ones that you are changing do have to comply with the current new codes. So additions to an existing building shall conform without requiring unaltered portion of the existing building to comply. So you're just adding this. It doesn't mean you have to do anything to this unaltered section. Additions shall comply with sections C405, which we looked at, and C406, which were the additional energy requirements. Alterations, so that was additions. So alterations, general alterations to any building structure shall comply with section C503 and the code for the new construction. Luminaire additions and alterations that add or replace 50% or more of the luminaires in the space. So replace 50% or more of the parking in different, whether it's a parking garage or total wattage of exterior luminaires shall comply with the codes that we looked at. Where less than 50% of the fixtures are being installed, the wattage shall be maintained or reduced. So you if you're doing less than 50% of the fixtures, you can't somehow end up increasing the load overall. As long as you're maintaining it or reducing it, you're in good shape. In Seattle, however, so we're looking 50% here. In Seattle, it's 20%, much more stringent. So be aware of that if you're doing something in the city of Seattle. System commissioning. So certified commissioning professional must be led by one of those. Testing the equipment, controlled receptacles and lighting control systems are subject to being commissioned. And exceptions are lighting control systems that are exempt from the commissioning process in buildings where the total installed lighting load is less than 20 kilowatts, and the lighting load controlled by occupancy sensors or automatic daylight controls is less than 10 kilowatts. It's only for the larger projects. So what is commissioning? We'll just kind of breeze through this, but it's a process that ensures all elements of the control system perform interactively according to design intent and the needs of the building owner. That's the IES. If we go to ASHRAE, they look at commissioning as a process that meets the defined objectives and criteria. And then there's a building commissioning association, and the basic purpose of the commissioning is to provide documented confirmation that the systems function in compliance with criteria set forth. So we see consistency through all of these definitions. Commissioning agents should be involved early on in the process. Otherwise, you can get into problems with who's responsible for what. Roles for the design and implementation need to be clearly defined, specified, and all installed, set up, operated to correctly, or it will not deliver the results expected. Okay, one more pop quiz, I think.
Yep, and it is the last one. Flowing it up right now. The Washington State Energy Code addresses areas as diverse as, and please select all that apply, elevators, egress lighting, receptacles, commissioning areas, and additions. All right. I see it over half voting, and there seems to be a pretty clear trend here.
Yep.
Closing in about 3 seconds. All right, thank you everybody who voted, and everyone's just paying attention. I appreciate it. Everyone pretty much selected everything 90% and above, except elevators. Actually, we got 70% elevators, and everything else was 90% or above.
Yeah, well, you know, there was another that might have been a little confusing. There's the mechanical lobby that has the thing, the 10-foot candles, but the Washington State Energy Code requires the 35 lumens per watt or greater. So there might have been a little confusion there, but yes, the code does address all of these issues, and then some. But these are some of the ones that you might get stuck on. All right. Did mention that we might touch on LEED. That's by the U.S. Green, U.S. GBC, U.S. Green Building Council. It's a voluntary measure, although sometimes not so voluntary. A lot of times you'll have a municipality that says if you build a library or you build a fire station or whatever, it needs to be minimum LEED silver or minimum LEED gold or whatever. So even though it's a voluntary thing, it's been chosen to be adopted by the area, let's say, that you're working in. And they cover a range of things: design and construction, residential, interior, and building operations and maintenance. There's also lead EB, which I don't actually see here, but that's existing buildings. You know, it's not a heavy lift for, especially if you're working in Seattle or even Washington State, where there's fairly progressive energy codes. You would choose 4 of the following strategies. So here's A through D, and then there's another 4 on the next page. So it's not that difficult. You know, you want to have look at glare issues. You want to look at high color rendering, light sources, long life light sources. You're minimizing the direct only overhead lighting for 25% or less of the total space. You want to look at surface reflectances, high surface reflectances, high reflectances off of your finishes, furniture, wall surface illumination. You don't want to just pool all the light in the middle of the space. And then you want to have ceiling luminance as well. So again, these are things that you'd probably already be doing, and you can get a lead point. There's another one for controls, a point for that, and 50% individual occupant spaces enable to the occupants to adjust the lighting. Well, that's required by code. For 100%, for all shared multi-occupant spaces, have multi-zone control systems enable occupants to adjust the lighting, and switch to manual controls must be located in the same space, again, required by code. So not hard to do with the Washington State Energy Code. Another one, though, that's gaining a lot of traction is the well building standard. And that more has to do, in particular, with occupant comfort and productivity. Guidelines minimize disrupt the circadian system, enhance productivity, and provide appropriate visual acuity. And so they have different categories like visual lighting design, circadian design, electric glare control, color quality, right to light, you know, being able to see outside, surface design, etc. So that may be one that you will choose. So you might remember we looked at that cover from the NEMA publication, all electric buildings. So that was back a couple of years ago, and so this is today, July 2020. All electric buildings, electrification in the code, and the concept of electrification, you know, is something that's being touted more and more. And at the 2021 IECC code development hearing, so they're talking now about what will come next year. NEMA said that this new code language requires that any appliance location in a dwelling unit that has a natural gas supply must also be provided with an equivalent electrical circuit. So if you're putting in gas water heaters, you have to have running a electric circuit to that location as well. So if you wanted to switch to electric, you wouldn't. It wouldn't be onerous to redo that utility system. As of this writing, several opponents to this code have filed an appeal to have it removed, but if the appeal is denied, it will be in the new IECC edition. Doesn't mean it will be adopted everywhere, but it will be there. So that's interesting to see. And then just to, you know, it's always something new. Who knows, maybe we won't be using electricity at all. Here's these ambient plant illumination could light the way for greener buildings. This is out of MIT news. And so instead they are infused with nanoparticles that turn the plant's stored energy into light. Not a lot of light right there, but you know, more to come perhaps. So that's all I've got. If there's any questions, I'll be hanging around. Otherwise, I appreciate you toughing it out. This is as I said, a kind of a dry topic, and I tried to make it as interesting as possible and cover areas that maybe you didn't think you needed to know about. So thanks again, and I'll turn it over to Armando.
Hey, Eric, thank you very much. That was pretty awesome. Thank you for helping break down the code for everyone on the call. I did want to mention that we got a couple people did comment at the very beginning. Hey, we are chuckling on mute at the joke you told at the beginning. So I just want to make sure that that is not missed.
Excellent. Thank you so much.
We do have a recent comment, if you want to address it, about including elevators in the lighting designer's scope, pretty much. Comment reads as follows. But as the lights within elevators are specified by the architect and the light need to be part of the elevator cab, they should not be installed in the field. So it is odd that this is part of the lighting designer's form. It is also odd that motor efficiency is included in this section rather than the mechanical section. Should that be something that should be changed? Elevators being taken out of the lighting energy section.
Yeah, let's go. It's sort of two parts. Well, let's cover the easy one first. So the section, the code comes from ASHRAE, and ASHRAE is the American Society of Heating and basically mechanical. I forget exactly what it stands for. I apologize, but and it's the entire building. It deals with building envelope, windows, mechanical systems. And so that the lighting section is actually called lighting and motors. And I don't know why. And, I think back when this got started, lighting was really not as much of a field as it is now, let's just say. At any rate, that it is what it is. As far as the elevator cars, we've seen elevator cars that are beautifully designed. I think the one I showed in the picture was rather elegant. So there's a lot of design that goes into that, and I'm sure that the owner and their design team have a lot of influence in that. And so, and in fact, the Lighting Design Lab did a mock-up a number of years ago with an architectural team to look at two different ways of doing elevator car lighting. They had their standard approach that the client usually used, and then the architect and their design team wanted to try something more innovative, something more interesting. And so, of course, in that process, you're going to be looking at different light sources, different ways of applying them. And so all this is saying is that whatever you choose has to be 35 lumens per watt or higher. So I think that it's not like you're just contacting, Otis, the elevator company, and saying, yeah, give us elevator type C. And I mean, it's possible that the elevator company would supply an elevator that already has lighting. But if you go to like hotels and offices, typically the lighting is a little more unique, and it's been design team driven. Hope that answers your question.
No, thank you very much for addressing that, Eric. Could you advance to the next slide, please?
Oh, absolutely.
Oh, sorry, I had the wrong contact information, but hey.
Yeah, if you like the presentation, tell me about it. If you didn't like it, contact Armando.
There you go. Great way to call it out. Hey, any questions or comments, you can always email us at lightingdesignlab@seattle.gov. Again, this presentation is going to be on our YouTube channel, or you can access the handout or a link to the recording on our resources tab on our website. Next slide, please, Eric. I want to give a shout out and a thank you to our partners that help us make our programming possible. Next slide, Eric. And that is all, folks. Thank you for joining us. You guys get a 5 whole minutes back to your life. Please don't forget to answer the 1-minute quiz after the presentation has been ended. And ultimately, thank you for joining us. Goodbye.